global transition to green hydrogen faces a hard geological limit. Proton exchange membrane electrolyzers require iridium, one of the rarest elements in the Earth's crust. Global annual supply is stagnant, averaging just 7.5 metric tons. As shown on the chart, this fixed supply is incompatible with decarbonization targets. Under the International Energy Agency's net zero pathway, iridium demand from electrolyzers will reach 21 metric tons by 2035. This single application would require nearly 3 times the current global production. The structural deficit manifests in 2029. At that point, electrolyzer manufacturing alone will consume over 112% of global supply. This physical bottleneck threatens to halt the scaling of the hydrogen economy. To bypass this bottleneck, manufacturers must reduce the amount of iridium used per kilowatt. At current commercial loading levels, allocating half of the global iridium supply limits annual manufacturing to just 8.75 gigawatts. Scaling to 70 gigawatts annually requires a 90% reduction in catalyst loading, down to 0.05 grams per kilowatt. However, this thrifting strategy faces severe physical constraints. Reducing iridium below this threshold accelerates membrane degradation at the anode. This shortens the operational lifespan of the electrolyzer stack below the 80,000-hour commercial benchmark. The industry faces a direct trade-off between material scarcity and equipment durability. The physical supply chain is highly concentrated. South Africa controls 83% of global iridium extraction. This concentrates the entire upstream supply chain within a single, fragile infrastructure network. South Africa's state utility, Eskom, suffers from chronic grid instability. Stage 6 power curtailments directly disrupt energy-intensive smelting and refining operations. This grid vulnerability makes global green hydrogen targets hostage to local power outages. Russia is the only significant alternative supplier, controlling 11% of global iridium. This concentration mirrors the 1970s catalytic converter crisis, which forced automakers to secure direct physical supply lines. Today, Western manufacturers face a choice between South African grid failure and Russian geopolitical risk.